Hello, we're going to look again today at exercise 16b. This is, well, it says 16B.2, but there's already been two different versions of exercise 16b. So in effect, this is the third video. And the person trying to do some kind of funny acrobatic thingamajiggy is represented in the fact that we are doing backward questions as well as some other bits and bobs here. Backward questions always make things a little bit harder. So they effectively tell us the variance, or they tell us a standard deviation. They say, what were the original numbers? I suppose something like that. But there's also another formula I need to show you as well. So up till now I've shown you these formulas, in fact. So this was the this was the standard deviation formula that we learnt last time. This was the mean formula that we learnt last time. And you need to learn these, x bar being the symbol for the mean, and the standard deviation is this is called sigma x. Sigma, so lowercase sigma. Actually, it's a bit weird that this is also called sigma. This is a capital sigma, and this one obviously as well is also a capital sigma. So you've got to learn these Greek letters. They come up all the time. So anyway, a little starter for us: the number of people who travel by train to work every day in 8 local authorities in the northeast of England was found. So last time I think there was a question on how many people went by taxi, and now it's a question of how many people went by train. Here are the summary statistics. So look, we've got no choice. We're not being told the numbers. We've got to use the summary statistics. So let's just go for what's it asked for, by the way. It wants the mean and the standard deviation. Rounded answers are 3 sig figs. Okay, so we just start off always by finding the x bar. X bar is the mean. It's sigma x over the n, which is 377. Now I need to go back to the question. 8 local authorities. So there's obviously n is 8 in this question. It doesn't say that. It says that in the word. So I'm going to write it there. So I'm going to just start off on my calculator, turn it on. 377 divided by 8 equals 47. Now it said 3 sig figs, so 47.1. But I'm going to write 125 initially, just to remind myself I need exact numbers perhaps. So even though I'm rounding it, I'm going to use it in a bit. I'm going to use the exact number there, 47.125. Then to find the standard deviation, then it says it's the square root of sigma x squared over n minus x bar squared. So let's do that sum. It's the square root of, what was that? It was 25719 divided by 8 minus 47.125 squared. And that's what I've got to type into my calculator. So let's do it. Square root of the fraction 25719 over 8 minus 47.125 squared. Okay, fair enough. 31.5. It says 529, but 5 to 1, or to 3 significant figures. So that's what I think the answer is. Let's see. Apparently it was in thousands, but yeah, I didn't really mind that. That's how many thousands of people travel by train every day, it seems, in 10 local authorities in the northeast of England. Okay, second question. So how does this formula work? Well, it basically relies on this idea of standard deviation. A standard deviation is on average how far each value is away from the mean. So you can imagine 3 numbers, 3, 8 and 10. I've made those numbers up. Now the total of those, that was lucky, the total is 21. So if I divide that by 3, it's 7. Now how far is each one away from the mean of 7? This is x bar, of course. Now this one is 1 away. This is 3 away. And this is, well, I suppose 4 away, but it's below it. Now if you was to just add up these average, this is like an average distance away from the mean. If you just add them up, you get 0. So one thing you can't do is just add them up. So what we tend to do instead is we tend to square them. 16, 1 and 9. And once I've squared them, I then add them up. That gives me 26. And that is written as the sum of all the values minus the x bar. Squared, and in this case it's, as I say, 26, and then the standard deviation, which we call sigma x, would be 26 divided by these three numbers and square root it. We squared before, so we square root again at the end. So if I do that, 26 divided by 3, and square root the answer, I get 2.9-ish. I'm going to write 2.9. So that's what we're doing on these questions. Let me just clear away all that rubbish I've written down, because what I want to do there is, now is just perhaps to practice this again. So this is my formula that I'm going to be using. This is like an alternative formula. So if I add up all those numbers, I'm just going to quickly do it on my calculator. So 49, turn it on, always helps. 49 plus 56 plus 55 plus 68 plus 61 plus 57 plus 61 plus 52 plus 63. I get 522. Now there's, how many of them are there? 1, 2, 3, 4, 5, 6, 7, 8, 9. So if I divide that by 9, I get an average of 58. So my x bar, my mean, I think is 58 for these numbers. How far is each one away from 58? Well, this one's lower, so this one's minus 9. This one's a little bit lower. This one's a little bit lower. And you can see this one's 10 higher. This one's 3 higher. This is a little bit lower, 1 lower in fact. 3 higher, 6 lower, and 5 higher. Now what I do is all those numbers, I square them. That's what the formula says here. You see it says xi minus x bar squared. So 81, 4, 9, 100, 9, 1, 9, 36, 25. Notice the minuses don't make any difference. I now add all those together. That gives me sigma x minus x bar squared. So I'm going to add all those up. 81 plus 4 plus 9 plus 100 plus 9 plus 1 plus 9 plus 36 plus 25. And I get 274. So notice what I now do is I divide that by the 8 numbers, was it? 1, 2, 3, 4, 5, 6, 7, 8, 9. Divide by 9 numbers. And I square root my answer. Divide by 9 equals, and square root my answer. And I get 5.52. So I'm not sure how accurate that is, but that's what I reckon the standard deviation of these numbers is. 5.52 is right, and 58 was right. So you'll notice there's a process by which you can go through these questions, and it allows you to find the mean in each case and then the standard deviation in each case. So this is a second formula which we need to know. Let's see if we can do it in this case. Notice this is all the work's been done for us. They've told us what this summary statistic is. That's the 508. So if I want the, it says find the standard deviation. Well, the standard deviation then is the square root of 508. I don't have to square it. It's already been, the squaring's already been done, and just divide it by 7. So it's square root of 508 divided by 7, and I get 8.52. And notice, please, if I didn't square root it, and I just had 508.7, that would be called the variance. The variance is the 8.52 squared, if you like. But when I do it really accurately, I get 72.6. Not sure if it would be quite that if I didn't do it accurately. 72.6. Backward questions. I did hint that we're going to get some backward questions. These are quite tough. So I suspect I'll be finishing these off in class, but I'll start us off now. We're given questions which require us to use the formula backward direction. That's basically it. So here we've got 12 students in a French class. In a 6-1 college. In the recent exam, their mean score was 50. So I'm going to write x bar is 50, and the standard deviation, sigma, equals 3. So that's my starting point. What's it say? A new student then joined the class. Oh, right. Well, how many people were in the class? There was originally 12. A new student then joined the class. Her exam score was 65. Find the new mean and the new standard deviation for all 13 students. Okay. Well, look, the trick here, and this is the plan that we're going to do. we need to first of all find sigma x. And our sigma x comes from here. Remember that x bar is sigma x over n. So if we ever need to find this total of what the numbers must add up to, this moves over and we can basically use this sigma x as x bar times by n. So in this case, my x bar was 50. I had 12 numbers, and if you do that you get 600. My numbers must add up to 600. Now, the new student got a score of 65, so my plan is to add 65 to the total that we got before, and I'm going to call that sigma y. Sigma y then is the 600 that we had before. That's what the original 12 students got between them. She got 65. We've now got a total of 665. And of course, once you know what you've got as a total, 665, you can now find a new mean, because it's 665. Now not divided by 12, because we now got 13 in the class. So it's 665 divided by 13. What's that? 51.2. I'm going to be as accurate as I can. 51.154, which is about equal to 51.2. Simply so that I've got reference to this more accurate version later on if I need it. I might not need it, who knows. So now I've got that, and let's just write it down on the next slide. So what did I have? I had y bar is 51 point. I've got y bar is 51.154. Now, the thing it says there next, of course, is that this new student comes along, and well, let's find our plan. What was our plan? Well, we need to work out what sigma x squared is, and we're using the sigma x to do that. So if I just show you this here, we've got a formula which says sigma x equals the square root of sigma x squared. You have to get used to this different notation, which sounding very similar, over n minus x bar squared. So I have to rearrange this equation, and then once I've got sigma x squared, I can then find what sigma y squared is, which is all 13 students, and then I can finally find sigma y. Notice this use of this new letter y. So if I do that, then I've said that sigma x is the square root of sigma x squared over n minus x bar squared. Now, first of all, move the square root over, I get sigma x squared. And also I know what that was actually. I can actually say that that was 3, so let's get rid of that and just write 3, because it says the standard deviation was 3 originally, equals, now I've moved the square root over, so I can just write sigma x squared, this is what I'm trying to find, over n, originally it was 12 students, minus x bar squared. What was x bar? Well, that was what we originally had. Let's go back and find it. It was originally, it was 50, so I didn't need to go back and find it. So minus 50 squared. So move the 50 squared over, that's 2,500, plus the 3 squared, so it's 2,509, equals sigma x squared over 12. Move the 12 over, that gives me sigma x squared equals, don't know what that is, 2,509 times by 12, 30,000 odd, 30,108. Now my plan basically is now to say, well, I know the new student scored 65. So to work out my new sigma squared, I have to square her 65 and add it on. So plus 65 squared. This gives me 34333. That's what the new sigma y squared is equal to. And what I can now do is I can now find sigma y equals the square root of 34333 divided by 13 minus y bar 51.154 squared. And I get that to be equal to 4.93. Don't know if it's right. 4.93. As you can see, it's quite a lot of work though, so we'll definitely practice these backward ones more. I think the first version, well, we'll probably be okay with that, but these backward questions, we'll need more of those for class. So next time we'll do this in lesson. Okay, bye.